Hello, this is Mr. Doty, and today I'm going to cover some of the things in descriptive geometry. I'm probably going to break this up into multiple videos just because I can, and I'm trying to come up with the best way to get this across. This subject's not the easiest thing in the world. I've got things like auxiliary views that we talk about. You guys look at some of the pieces on the descriptive one, the geometry one, descriptive geometry 2, and let's see, I have this one too. This is, I think, out of an older book. But you're like, what the heck is descriptive geometry, and where in the world am I going to ever use this? Well, if you were in civil engineering, for one, you can do it to figure out your cuts and your fills for installing a road, or the beginnings or landing. I forget what the exact correct terminology is. But for bridges, if you're building the, pillars that they sit on, then you have to know where that, sits, and if you have a valley that moves up and down like so, well, you're going to have to figure out, the true length and the bearing and so on of these things. Now, something else, like if you have a mine, and you want to figure out what angle that shaft has to go down, or figure out where the deposit is that you're trying to get to, so that you have to figure out maybe what something the angle is to get to it. This is all talking about cuts and fills. Something else is when you're talking about sheet metal, trying to figure out, how to lay out sheet metal and get, these strange angled pieces of ductwork possibly. Also, laying out pieces of property, you need to know bearings. You have to know your directions. You have to figure out slopes and grades, things like that, so that you can, these are all related to basically civil engineering kind of things. So that's part of what descriptive geometry is. Like there's things that we're not even going to do, like there's strike and dip of a vein given two lines in a plane of a vein intersecting. Well, these are all based off of the simple principles of trying to find the true length of a line, trying to find the true shape of a surface or a plane. Like example here, this is just a part, and basically the chapter 9 part of this, where we're doing auxiliary views, that's basically what this is, because I have to find the edge view of something, and the only way I can find the edge view of something is if I have the true length of it. So if I find the true length of this surface here, then I can actually show what the true shape and size of it is. And that's really what we're trying to do. We're just trying to be able to find the exact dimensions for something so that we can make it. If you don't have those dimensions, how are you going to make it? So, there's, like I said, there's all kinds of different uses for descriptive geometry, and we're just touching on the surface of it, okay? For those of you that have taken some parametric modeling, either Inventor or SolidWorks, we can rotate our models around to look at the surface that we want to look at. Well, when we create views of those surfaces, of those parts, we have to create things called auxiliary views, or if it's not parallel to any kind of surface here, this one I would probably have to do 2 auxiliary views. So you'd have to flip it twice basically, or maybe 3 times, You have to figure out where's the true length. Then you have to figure out what's the point view off of that. And then you have to flip it back to find the true shape and size. So these are all things that, whether you understand or it makes any sense to you, I get that. I had a whole class on this. In fact, we used to teach a whole class on this. And we would even try to figure out, what is the intersection points of, where does a plane intersect another object. Or, one of the problems on here is, I believe it's down here at the bottom. Let's go find it here. But, well, look, you've got a tower here, and you've got a line going from the top of the tower going down here to the roof down inside. Or maybe it's a cable for connecting something or the other. Whatever it is, I have to figure out how much, whatever this material is. Let's say it's a cable. How much cable do I need from point A to point B? Well, descriptive geometry can help me figure that out instead of just guesstimating it, right? Because I have to I have to be looking straight at this so that I can find, see, it's not straight. It's not parallel with one of my lines here. Now, if it was parallel up here, then it'd be true length down here. Well, it's not, obviously, so I need to figure out by finding the true length, then I can figure out how much of that material I actually need. So those are some things that we can use descriptive geometry for. So when you tell me that you don't understand why the heck we need descriptive geometry, well, when you're working something like this where you have two planes and you have to figure out which one is in front of the other, how they intersect. Well, one of the problems that we work is you've got two pipes and you want to figure out if they hit or not, if they're spaced far enough apart. Well, if you're running duct work or if you're running pipes in a building, let's say you're using even Revit, well, one of the things that the computer does for us somewhat is helps us to figure out interferences. Well, what if we don't have access to a computer program to help us do that? What if we're given something simple that we need to figure it out? We use descriptive geometry to do that. So, it may not be necessarily something that you're going to use every day, but, look at this. You have a dihedral angle. I don't have you do this, but basically you have to find the edge view of that angle. That's what you do. So you have to find the true length of the where the vertex of it, and when you find that, then you can flip it 90 degrees and find the dihedral angle. So we're not even doing that. Okay, this is a piece of sheet metal, basically. It's converting from this rectangle to this rectangle. How do I figure that out? How much material I'm going to need. And when we create sheet metal drawings in SolidWorks or an Inventor, it's doing this unfolding for us. But we could figure it out manually if we wanted to. So part of this is, if you think about, why do I use math? Why do I have to learn math in school? I learn math in school because it helps me to solve problems. It helps me to understand how to use numbers to solve a problem. Well, in drafting, we use pictures, we use numbers, we use notes, words, whatever it is, measurements, to describe everything. Now vectors, those are just, never really understood them myself, so anyway, I would never cover all that, but and that's starting to get into more like calculus or a little more trig, and those are things that those are important too, but figuring out force, directions of force and things like that. But that's not something that I'm, that's important for me right now or for you right now. But what I'm trying to get across to you is descriptive geometry, yeah, it's weird. Sure, it's weird. But like here, look, let's just use this vector in example here. You know, they've got a 10-pound weight, an 8-pound weight, and a 6-pound weight. So they're trying to figure out, you know, what angle this is going to create. Why does that matter? I don't know. Maybe it has something to do with, you know, clearance. They're trying to figure out if they have enough clearance, you know, if this is at 10 and this is 8 and this is 6. So those are things that, you know, maybe that's a practical use for it. All right. Let's see. What are we on? Descriptive 2. All right. So look at this. You have a crane, and I didn't make you do this one either, but it says true length and slope. A crane is mounted on the bow of a boat as shown. Find the true length and the slope of the cable AB and the support structure. Well, this is our support structure, right? So why do I need to find that out information? Well, if I don't figure that out, I can't figure out how to make it. So that's another place where we can use descriptive geometry. The slope and grade, which I do have you do, those are things that you have to figure out. So you're making a road and you want to figure out the angle so that you don't make it too steep for, let's say, a semi to be able to go up, or a piece of equipment to be able to go up or down, you know, without having issues or, you know, having a runaway, you know, dangerous situation. That's why we need to figure out the slope and the grade. The bearing is where we have to lay out some property and figure out how something works. Alright, so this one, let's see, is this the one with the antenna? True length, true angle. Shows the adjacent front horizontal views of a roof, location where the antenna is going to be mounted. You know, I used to do this one when I taught the full class, so that you had to figure out, you know, where this antenna is located, and then I think you had to figure out, yeah, you had to figure out the total length of the guy wire needed to stabilize your antenna to the nearest foot. So these are practical applications of descriptive geometry. I'm trying to solve a problem. I'm trying to figure out if these pipes intersect or how close they are, so that I can figure out if it's, you know, my design's going to work. You know, those are all things that we have to do. So height above the ground for the ridge, they're trying to figure out something to do with a chimney here. Let's see. Not visibility, dihedral angle, given the two adjacent front horizontal views of a laundry chute. Oh, this is the laundry chute. Find the true angle between sides A and B. So this here's another one where you're doing sheet metal and you're trying to figure out, you know, what's the true shape, true length, you know, size of these pieces so that you can make it work. Well, the cool thing is we've got things like SolidWorks or Inventor that helps us to visualize these things a little easier than what we're doing here. So that's why I'm not having you do this kind of stuff. I'm trying to keep it simple. You know, there's certain things that you have to have to, whoops. Well, hang on. So this is auxiliary views. Is that the only one I pulled up? Okay. So basically, let's see, where's it at? So, well, one of the things that we go over on here, so we just think about auxiliary views. Auxiliary views going along with the first part of the descriptive geometry, it's basically the same thing. So it says to understand how to generate views that show inclined and oblique surfaces. What's an oblique surface? Well, that means that it's not parallel to, you know, your screen, if you will, or you're viewing, you know, you're looking straight at it. Well, you're not looking straight at it. It's foreshortened. It's at an angle. And in another video, I'll show you something that I've drawn up that is very similar to this. That may or may not go with this, but it's fine. Hopefully this may actually show you what you need to know, and I may not even need to do that one, but I drew it up, so I'm going to show you anyway. Definitions and use, fold line method, primary auxiliary views, secondary auxiliary views. Well, that's whenever you can't just flip it once. You know, it's one of those deals where you have to flip it twice or 3 times to figure it out. So the other thing when we're talking about this is what are your principal planes that you're dealing with? Well, if you think about it in SolidWorks and Inventor, you have 3 basic planes that you start off with. Those are also called datums because they're references, okay? They're reference planes or reference surfaces. Well, a plane is a surface. A plane is just something that it doesn't necessarily have. It just has, you know, a direction basically. So you have your horizontal plane, which is your top and your bottom view. You have the frontal, oh hey, front view, makes sense. And then back view. And then you have your profiles or your side views. And those are your principal planes, right? Well, if you look at your modelers, they have 3 planes you start with. They may say X, Y, and Z. They might say front, right, and top. You know, just depends on how the modeler, how they programmed it to, you know, show up. Whoops, going too fast here. Alright, so auxiliary views, basically it's an orthographic view that projected into a plane that's not parallel to any of the principal planes. Alright, so what does that mean? Well, that's like going over here to Descriptive Geometry 1 and looking at this surface. That's this guy right here. I draw this guy, I'm going to flip him up 90 degrees so that I can see the true shape and size. I need to have 2 views to do that. Okay? I just need 2. A front and a side, a front and a top, whatever, to get this so that I can project off of one, measure off the other. So when we're talking about doing the true length of a line, you project off of one view and you go to the other view and measure. If you can get that straight, everything else is easy. Okay? You have to have a true length line before you can get a point view. Yeah, and you have to get a true length line before you can get the actual slope as well. Okay, so moving along, let's see what else we can get into here. Alright, the purpose is to show the true shape and size of a detail that does not lie in the principal planes. Okay, that's an auxiliary view. Fold line method. Okay, basically when you learn how to do orthographic projection, we just don't draw in the fold lines. You know, we just project to the different, you know, and we use our little miter line up here, you know, a little cheat, right? Well, on this, it's the same idea, except that we have these located at specific distances off of the fold line so that this distance here is equal to this distance here. Okay? That's the only difference in using fold lines and doing your normal orthographic projection. We just, you know, simplified it and didn't make you try to figure out, you know, how far it was from each other. And this is the same idea, fold line. Alright, so these are fold lines. There's our, you know, points. And then this is view A, and this is view C, view B. You know, you're just projecting. Okay? And apparently I'm going to have a visitor from my cat, but we'll see. Luckily, I'm not actually on camera, or you can hear the cat might, you know, come and visit. So, anyway, that's just the way it is. Anytime you try to work down in the basement, it kind of works that way. So, yeah. All right. So, when we're using, when we're drawing up our, you know, our auxiliary views and stuff, you're going to be using AutoCAD because I want you to do it the old-fashioned way and to have some kind of idea what the heck you're doing. And it's okay if you don't quite get it at first. It's kind of like orthographic projection. You just have to figure it out. And, you know, it took me a week or two before I really kind of understood how to draw views. Well, I went through a whole semester of descriptive geometry and I sort of understood it. And we did it by hand. We didn't, you know, mine was all manual drafting. You know, we didn't even use CAD for it. Which in some cases it kind of, it does, I think if you use your, basic AutoCAD, it helps you to understand a little better. But we can use modelers to kind of show it too. But I don't have one installed on this computer right now. So, for right now, just for this video, which is starting to be about 20 minutes long or so, I just wanted to kind of go over, just like an introductory, of what the heck is descriptive geometry and why in the world do you even want to use it. I may even come up with a better version of this, who knows. Alright, here's an example here. Look, you've got this inclined surface. You'll notice that I'm looking at the edge view of it, right? So that means it's true length. It's foreshortened here, it's foreshortened here. But, like this line right here is true length up here. I'm projecting off of this, so I can measure off of either one of these views that I have to get this distance here. So I've got one, it comes over here, it projects up, it projects at 90 degrees. Okay? And then these lines are parallel with my fold line. So this is parallel here, so this is true length here. Alright? This line, if I was talking about this line right here, it's parallel with the fold line, so then it's true length over here. But I'm not looking for that line, I'm looking for 1, 3, and it's, it's short. But it's parallel here, true length here. Okay? Anyway, moving along. So a line which is perpendicular to the projection plane appears as a point. Of course it does. So when we project this 3, 4 over to here, it becomes a point view. Then when we flip it back 90 degrees, it's true length, and that's how you get your true shape and size. I know sometimes you may not understand it, and it's okay. Just do the best you can with this, and we'll get through it. We'll figure it out. Okay, let's see. All adjacent views. We'll show the line true length. I've already talked about that. Surfaces appear as true shape if it is parallel to the projection plane, and that one is. Alright, so when you talk about secondary auxiliary views, then your brain starts kind of getting the mush, and you're like, oh, okay. Well, basically it just means that you got to flip it twice. So this surface here, this is foreshortened, this is foreshortened, this is foreshortened. I have to find the true length of something, which I found the true length here, which turns into an edge view, right? Well, if I have the edge view of that, then I can flip it 90 degrees, which is what you do whenever you do your fold line, and you come up with, well, let's find where it goes. So this kind of looked funny to me when I looked at it a minute ago. So we've got this view, and this view, and your projector lines, which they should have used something besides colors. Should have used like phantom lines or something. So they project their points, right? And then they create another view. Well, so they're finding the true length of this line. So if it's true length here, oh right, it's parallel here, so that's 1, 2. If it's parallel there, it's true length here. And so if it's true length here, then you can find the point view of it. Alright, and that gives us, when we project it over, that gives us this edge view, which then in turn gives us the true shape and size of, that I really just want this surface here. So anyway, if that blows your mind, it's okay, no big deal. See, they're kind of simplifying it here, where they've got this surface is shown there, there, and there. If you take the rest of the piece out of it, this is what we're doing, and this is basically what you're going to do. Okay, so don't be afraid. Don't think this is the worst thing that you've ever had to deal with. It'll be all right. And we'll figure it out. Now, something I did want you to see here is that we'll cover it a little bit later maybe, or it may be in one of my other videos, is if you have a triangle like this and you don't have any lines that are parallel, you can make one. Just add another point, make this parallel, that makes this true length. Well, once it's true length, what can you do? You can flip it 90 degrees and go down here most likely and create your edge view, and then flip it again, right? So you go perpendicular to it to get your point view or edge view, and then you go parallel to get your true shape and size. Alright, so here we go. Here's our edge view right here, see? So parallel, true length, flip it perpendicular to our true length line, gives us our point view, which then gives us our true shape and size. So whatever view you project off of, you measure back here off of this one. Okay? Remember that. It's the way it works. I'm projecting off of, well, I drew this view here, so that created this one. So when I'm creating this one, I'm projecting off of here and measuring from back here. I always try to tell people to go 2 back. But just remember, you can't measure off of the view you're projecting from. Okay? Basic rule. And we'll get to this in some other videos. And this one's gone on pretty good. So hopefully this helps out and, maybe clarifies a little bit why the heck we're doing this. Just look at it. This is a front view, this is a top view, this is a side view. That's all. It's just the same idea what you've already learned how to do. We're just applying it in a different way. And, the different things that you can do with it, whether it's you're finding the surface or you're trying to figure out, the shape of some sheet metal, how it's laid out, how you're going to do this flashing, or how does this, the angle, the slope of the roof, how does that affect, how your chimney is going to sit in there, or like this little, we call it a cricket, sort of, but it's also a little gable end there sticking up. Maybe you need to figure that out. A lot of times our software does it for us, but this is just basic stuff to help you solve a problem. Okay? Basic idea is just solving a problem. And sure, we have software now that does a lot of this for us, but what I'm trying to do is give you some simple things. I'm not even making you do this thing with the antenna. I could make you do that, but it's just an example of, trying to figure out how much wire you need. Well, you've got to figure out your attachment points and everything, and, that's important to know. Or your clearance between pipes. Those kinds of things. So, anyway, I just wanted to throw all this at you and see if it sticks. And hopefully we will come up with some more videos that maybe clarify this mystical thing called descriptive geometry. Alright, well, that's all I've got for now, and I hope this helped out somewhat, and we'll see what we can come up with some more. Take care and have fun.